Okay, so for today's lesson, the last one of the derivative unit, we're going to be doing higher order derivatives. So this is like taking the derivative of a derivative, and then we can also take the derivative of a derivative, which we took the derivative of already. Lots of derivative-ception going on. If anybody likes the Inception movies, yeah, those are super cool, right? So yeah, so like derivative-ception, essentially. You should watch it if you haven't seen it. It's pretty.
Is it like sci-fi?
Yes. Yeah, it's like about time travel and they're like infiltrating people's dreams and stuff like that. So they like make decisions in the real world. It's really cool. Leonardo DiCaprio, Joseph Gordon-Levitt, and somebody else is good.
That's Leonardo DiCaprio, right?
Yeah. Wait, what?
In the movie, right?
Yeah.
Inception?
Yes.
Oh, I
Yes.
was like, oh my gosh.
Yeah.
DiCaprio, he's cool, so he's dumb. Sorry.
No, it's okay. Anyways, a little sidetrack. So I hope when you watch this, if you watch this video again, you'll get a little chuckle after that. Okay, so higher order derivatives is what we're doing. So can we take the derivative of a derivative? Yes. Oh, apparently not.
Just kidding.
Yes, we can. Okay, this is called higher order derivatives. Okay, so we kind of talked about this yesterday, how we can have position written as a function of time, right? So like a displacement time graph. This will, if we find the rate of change on a displacement time graph, this will tell us the velocity of that object that is moving, right? So, how do I want to do this? Oh. Okay, so for example, so like S is going to be our displacement, okay? So displacement is going to be a function of time, okay? And we're going to use S for displacement in calculus, just because. Okay, so if we take the derivative of S, like we've kind of been doing, so we take the derivative of speed or displacement with respect to time. Okay, and then the rate at which the position is changing with respect to time is our velocity, right? Right, so if we have a displacement of like 10 meters over 2 seconds, the rate of change would be 10 divided by 2, so that would be 5 meters per second. Okay, so V, so velocity, is equal to S prime, so the derivative of displacement. So S prime or ds over dt, derivative of speed, displacement with respect to time. Or another way we can say this is F prime of t. So we can also do the same like we did. So if we plot a velocity time graph, if we find the rate of change on that particular graph, we can find the rate of acceleration for that, okay? So if we take the derivative of velocity with respect to time, that will be acceleration. Okay, that is physics 20. So we could also say that acceleration is equal to v prime, so the derivative of velocity, which is also the derivative of displacement over with respect to time. Or we can also say f prime, so it'd be the derivative of f prime of t with respect to time. So these are just 3 ways that we can kind of say this here. Okay, so when we get into module 6, so that is actually the applications of derivatives. We will get into that a little bit now, a little bit later. But for now, we just need to know how to find like the second or the third derivative given a function. Okay. So we have some notation here. So the first derivative, there's going to be like 1, 2, 3, 4, 5 different ways that we can say this. Okay. And they're all kind of interchangeable. And you guys will be somewhat familiar with some of them. So first derivative, we could take the derivative of f of x with respect to x. Or we could also say the derivative of y with respect to x. Or we could also say f prime of x. Or we could say y prime. Or, oh, that's red. Or we could say, what do we else we got? We got dx, derivative of x, sorry, that's a capital D. I know there's a lot here. Derivative of x as a function of x. Or we could go one more. We could take the derivative of x dx y. So there are a few ways that we can show or communicate to whoever that we're taking the first derivative. Okay, so if we have this, we pronounce that one the derivative of y with respect to x. This is going to be f prime of x, and this is y prime.
Why is it a capital D? Does that change anything or no?
No, I think it's just like the notation of the derivative itself. Yeah.
It's just because a lot of people came up with different things and we're just going to use them.
Yeah, exactly. They're like, we're not going to pick favorites. We'll just do a little bit of everything. Okay. So going into our second derivative. So the derivative of dy over dx. So that can be a second derivative. Or we also have d squared y over dx squared. Or we can also go f double prime of x. Or our y double prime as well. Or d2 x f of x. Okay, you're not expected to memorize this list by any means. Okay, I just want to say that right now. This is just, you might just see these in the future. So just kind of be able to recognize that. Okay, and then last one we have d squared x of y. Okay, so the big ones are just like, these are primes, right? So f prime of x, so f double prime of x, y double prime, f prime of x, y prime. Okay, so those are the big ones there. Make sure you're able to identify the primes. Okay, we will get into our third derivative next. So we have d3y with respect to x, or y triple prime, or f triple prime of x, or d3 x f of x, or our last one here, d3 x y.
The only acceptable one of these is the y prime.
Yeah,
Y double prime.
I agree. If we can just leave it in this notation here, I'm totally happy with that. Triple prime, y prime, yeah. Okay, so for fourth derivatives and higher, we're gonna stop there. So the primes are not used. But instead, we will use the number of the derivative in brackets. Okay, so for example, it would be y to the 4 or f to the 4 of x or y to the 5 or f to the 5 of x.
Was that of supposed to be an or?
Yep,
Okay.
it sure is. Thank you.
I just wasn't sure if it was like y to the 4 of f.
Yeah, no, that's a good question. Yeah. So again, you don't have to memorize these by any means, but just be able to kind of recognize it when the question is like, find d squared y over dx squared kind of thing. Anytime you just see like the 2's or the 3's in it, that's just a really like a good way to check, right? Yeah, that's how I would just recommend it. 3 means 3, 2 means 2, right? And if there's nothing, if it's just dy of dx, that's just going to be the first derivative of something. Okay? So if our function is y is equal to x to the 3 minus 2x squared, find the first derivative and also find the second derivative. Okay, I forgot to do attendance, so try this one on your own. So it's literally, no, like seriously, like just, so find y prime, so differentiate this, right? So then you'll get what? 3x squared minus 4x, right? And then differentiate 3x squared minus 4x again. That's it.
Okay.
Okay. So we have our just our regular function. So we'll find dy over dx. If you wanted to say like y prime instead too, that's fine. Okay, so the derivative of y with respect to x would just be 3x squared minus 4x. Right? All good? Okay, so then, sorry, you're good?
Yeah, I did. Yeah.
Okay, cool. So then we will just differentiate this a second time. So this will become 6x minus 4. That's it.
I can't find a derivative always be different.
This is my type of calculus.
Right? I like this. Okay. This one's gonna be a little bit more tricky.
What is the limit?
Sorry?
I like the limit.
The limits, yeah. The limit did exist.
Yeah,
Limits
that
are fun.
was good. I like graphs. Graphs are cool.
This has been my favorite one to teach so far.
Derivatives?
Yeah. Just because I have a little bit of background. It wasn't like completely foreign to me. Okay, so what derivative rule must we use for this one?
Quotient.
The quotient rule. Good eye. Okay.
Good eye, right?
So the quotient rule, y prime is equal to v times u prime minus u times v prime over v squared. Okay, so u will be the numerator and v will be the denominator. So u is x plus 1, v is x minus 1. So u prime will just be 1, right? And v prime will also just be 1. Okay, so let's find y prime. So y prime is equal to v times u. So x minus 1 multiplied by 1, subtract u, x plus 1, multiplied by v prime, which is 1, divided by v squared, so x minus 1 squared. Okay, so we multiply these by 1, nothing will change. So we can just rewrite that. So y prime is equal to x minus 1 minus x plus 1 over x minus 1 squared. Okay, we can distribute this negative inside. So we will get y prime is equal to x minus 1 minus x minus 1 over x minus 1 to the 2. Positive x, negative x, bye-bye. Negative 1, take away 1 again, we'll get negative 2. So y prime is equal to negative 2 over x minus 1 squared. This is a nice quotient rule question, right? Yeah.
Yeah.
Yeah, I agree. Okay, but what was the question asking us for?
Why?
Y to the 3. So we need to differentiate this again. So what rule will we use for this function?
Quotient.
Yeah. Woo. Okay. All good? Because we do have a fraction. Indeed. Chain rule for the bottom one.
Or would you just
You can just leave it because, so are you talking about like this step here?
like just for
Just-
x minus 1 squared?
Yeah, like do you want, oh, okay, because the chain rule for that one, no, we will not. Because what, if we take the derivative, no, we just want to use the quotient rule here. I see why you want to take the chain rule, but the quotient rule will be much better for us, okay? Because when we do differentiate using the quotient rule, I want to say, we don't need to use the chain rule unless we have something that could use the chain rule. Sorry, that's a terrible explanation. Don't use the chain rule here, just quotient rule, okay? Cool. So we will say, so u is our numerator, so u will be -2, and v will be our denominator, which is x minus 1 to the 2. Oh, okay. Aaron, remember when you said you wanted to do the chain rule?
Yes.
Yes, we will. When we differentiate v here, so that is when you're going to apply your chain rule. Yeah. Okay, sorry. Okay, so u prime of -2 is going to be 0, and v prime will be 2 multiply. So we'll take the exponent, put it up front, x minus 1, subtract 1 from the numerator, multiplied by what is it? The derivative of what's inside the bracket, so this be 1.
Can I just skip straight to 2x minus 3?
Yeah. So that's where we're gonna get to eventually, right? But Samson, I would leave it in 2x minus 1 form. Okay, so now that we have u prime and v prime, we will substitute this in. So remember quotient rule. So So y double prime is still going to be v times u prime minus u times v prime over v squared. So v x minus 1 squared times u prime, which is 0, minus u, so negative 2, multiplied by v prime, which would be 2 x minus 1. Over v squared. So I'll have x minus 1 squared. Okay, so 0 multiplied by x minus 1 is 0. Here we will have negative 2 multiplied by 2 will, so negative multiplied by a negative gives us a positive multiplied by that. So will give us plus 4. And then we'll have our x minus 1 in brackets still over x minus 1 squared will give us x minus 1 to the 4. Okay, we can get rid of this, and this will become a 3. That is only y to the second prime. Are we all able to get there so far? Perfect. So then we'll just do the same thing that we did. Now we just need to find y triple prime. So again, v times u prime minus u times v prime over v squared. U is our numerator, so u is equal to 4. U prime is equal to 0. V is x minus 1 to the 3. V prime is equal to 3 multiplied by x minus 1 multiplied by 1. And don't forget your exponent up there like I almost did. And we do not want to expand that either. So we'll just clean that up. V prime is equal to 3 x minus 1 squared. Okay, now that we know u and u prime and v prime, we can just substitute that in to the quotient rule equation. So y triple prime is equal to x minus 1 to the 3 multiplied by u prime, which is 0. Subtract u, which is 4, multiplied by v prime, which is 3 x minus 1 to the squared. All over our v squared. So x minus 1 to the 3 squared. Okay, so same thing. If it's multiplied by 0, it will just become 0. 4 multiplied by 3 will give us negative 12 x minus 1 squared over x minus 1 to the cubed squared would become x minus 1 to the 6. Okay, we have x minus 1 on the numerator and x minus 1 on the denominator. So this will go away. If we subtract 2 from the top, we will be left with 4. So then we'll get y triple prime is equal to negative 12 over x minus 1 to to the 4. Whew. That was tiring. Yeah.
That's a long one.
3 derivatives. And we could continue and take more derivatives if we wanted to, but I think that's enough, hey?
Yes.
Yeah.
I think we should 6 times.
6 times? You want to find the 6th derivative?
A short way to-
Wink, wink.